excited to have Professor Dan Schwartz here to moderate. For those of you who do not know, Professor Schwartz is our Clean Energy Institute director. He's a faculty in chemical engineering, and he's one of the leading people in the state in really directing sort of the future of clean energy technologies. So we're pretty fortunate to have him as a ChemE professor, and also any of you who have him as advisor are very lucky because he's an awesome mentor, an awesome advisor as well. So we're very excited to have him moderate today, and he is going to introduce and kick off our panel with Wes and Katie and Sam.
Well, thanks so much, Elizabeth. Really appreciate everybody coming in today, and I do understand that there's been some traffic problems. So those of you that are in the classroom, thanks for coming. Today, I'm going to let our speakers, Wes Williamson, Katie McClintock, and Sam Landsman, do their own introductions, tell a little bit sort of about where they're working now, their current jobs, roles, and a brief description of those, and then we'll get into questions. So Wes, can I kick it off having you do a personal introduction?
Yeah, absolutely. So like Dan said, Wesley Williamson. I got my bachelor's in ChemE from Georgia Tech, graduating back in 2012, and got my master's from UW, graduating in, what was it, I think 2017, 2018, after working with Dr. Hillhouse doing some of the PV research. After graduating, I landed at PSC, kind of super motivated by all the clean energy work that I was doing at UW, and kind of saw PSC having opportunity for me to do that and kind of bring that to scale. So started off here in our transmission engineering group. So very not traditional ChemE, a lot more civil mechanical type work, poles and wires and keeping things in the air. But then rotating to a new product development group where I supported our first installations of car chargers and utility funded solar installations. Actually, one of our most recent installations is with the city of Sammamish. So appreciate the opportunity to partner with them. And most recently, I have joined our strategic system planning group where I get to think about how our infrastructure needs to be planned out and built out for the next decade or so.
Thanks so much, Wes. Katie, can I go to you next?
Yeah, hi, good morning, all. I graduated with a BS in chemical engineering in 2003, so 19 years ago. Time has flown by. I originally worked briefly at a pharmaceutical company part-time, and then got hired at the EPA into their sort of new hire program, which is a great option. If people are coming out of college, it's pretty hard to get into EPA unless you come in right out of school. And I was hired into our air enforcement section. So I used my chemical engineering skills to develop cases against large air pollution sources, think refineries, glass plants, cement, steel, whatever you can think of that produces air emissions, pulp and paper. So we would try to develop cases and explain why we thought that they had violated the air laws. And then we worked with our attorneys to actually bring lawsuits against them. And I quickly became the national glass expert, sort of building on my knowledge in school. I picked up more and more knowledge, and then I worked part-time for our headquarters division, and I led all the national cases against glass plants, specifically container and flat glass. And then from there, about 5 years ago, I stepped up into management and was managing our air enforcement group. And then about 3 years ago, took over also managing our pesticides enforcement and our lead paint enforcement, which have been really interesting, especially pesticides. It's an area of sort of chemical engineering that I hadn't really thought about, and I've learned a ton. So managing was a whole new experience, using more soft skills than my engineering skills, but needing to have that engineering basis to be successful. And then about 3 months ago, I made the decision to take a break from working, and I am now a stay-at-home mom for a little bit. I do plan to return, but balancing career and family was exhausting through the pandemic, and I decided to listen to myself and take a break. So that's what I'm doing right now.
Thank you, Katie. Sam, last but not least.
Hi, everyone. Sam Landsman. I graduated UW ChemE 2015. Go Dogs. I knew when I started school that I wanted to work in water. I didn't really know what that meant, but I decided to go with ChemE as opposed to civil and environmental, because I thought, okay, all the processing classes and such would be very nice, as opposed to, like traffic engineering, I was less interested in surveying and such. So I did ChemE and then worked in an environmental lab through undergrad. And then at first job at school, was working at CH2M. It's now Jacobs. It's just one of the big, civil engineering consulting firms. And I decided I wanted to work for them because they built the Cedar River water treatment plant that serves UW and many of the surrounding areas. And I thought, oh, wow, our drinking water is really good. And this company designed, built, and operated it. Cool. So I did that. And then after about a year and a half, I went to Berkeley for graduate school, did a year of environmental engineering to try to get some more I guess actually have like a civil/environmental engineering degree, since I was working in that field. But really it's just environmental, not civil, even though my title has been civil engineer. And then I worked another consulting job at CDM Smith down in LA for 2 years, working on bottle recycling projects in desal. And then when the pandemic hit, I ended up taking a year off and I moved back home, took some time off, worked on music, which is a big hobby outside of work. And then I started working again in January of this year, but I'm in the public sector now, working for City of Issaquah. Hooray, doing more development review for anything from somebody remodeling their house to a giant apartment building, to a Jackson's like gas station store, and just making sure that all the utility hookups and site grading and handling of hazardous substances and so anything like that is up to code. And if it gets built, will serve the citizens of Issaquah well. So kind of a different side of things. And frankly, I'm enjoying the public sector more so than the private sector right now.
That is fantastic. Thank you, all three of you. So I want to get a little deeper. You introduced sort of the kinds of jobs you've had and some of the evolution that you've had in your roles. And I'm just curious if you could talk a little bit more about sort of what is the day-to-day of an engineer working in your sector look like, maybe earlier in your career versus what you're doing right now. And even though Wes has had several different jobs, you're still fairly early in your career moving up. So, I mean, just talk about sort of how is it evolving? What do you do on a day-to-day basis? Why don't I start with Katie this time?
Sure. So in my role in developing air enforcement cases, we were really trying to understand what was happening on the process level that would be creating air emissions, and then trying to figure out what changes in the process would make those emissions go up or down. So at a glass plant, we'd be looking at, okay, what are the sources of particulate matter and SO2 and NOx? And if the company is saying we're going to switch from using direct air in our combustion to using 90% pure oxygen, how is that going to affect emissions? And a company might say something like, well, everything will go down, it's better for everybody. And we'd have to dig in and say, okay, for NOx, yeah, if you're not having a bunch of nitrogen, you're going to have a real reduction in emissions, but by using pure oxygen, you're going to raise the temperature in the furnace, which could increase volatilization. And, so PM and SO2 may not go down, and it might depend on your design. So we ended up really, one of the interesting things about in the public sector for me was that we always knew a little bit less than the people who were in the private sector. They did this every single day, and I had a bunch of other things I was working on, but I needed to go toe to toe with them and call them on things that seemed technically inaccurate. And I needed to have the confidence and the ability to do quick research and say, okay, this doesn't seem right. You need to explain this. And usually we were right, and they would eventually back down once they got pushed. But it took a lot of confidence in my knowledge as an engineer to be able to say, I really think what you're presenting to these agencies is wrong. And that was pretty much what we did, is continue that cycle, do research, present it, and try to win those arguments over and over again.
That's super great. Wes, do you want to comment?
Yeah, I can share kind of my day today. So for PSC, for engineers below a certain level, the company encourages, requires folks to do a number of rotations to kind of gain breadth of experience, which I think is super cool. And there's not like a really defined set. Okay, you have to be in this group, you have to be in this group, you have to be in this group. But the idea is you start kind of with what is the company's foundational business, and then maybe you do something that's a little bit kind of higher in knowledge tree. And then finally, your third rotation, you're probably now working on more of the strategic and business priorities. When I first joined PSE, I came into the electric transmission engineering group. So kind of like I briefly mentioned, they're the people who put poles in the ground and keep the high voltage transmission wires in the air. I will say when I first joined, as I was going through the interviews, one of the engineers was like, okay, so what the heck are you going to do as a chemical engineer? You're going to look at like the pole treatment leaching out into the ground and environmental and wetland concerns? And no, not me. I jumped right in learning some of the basic kind of modeling and the mechanical and civil engineering that goes into thinking about those things. And so ultimately, I got pretty quick to the point where I was doing projects where it was, one pole, miles of poles, maintenance projects, working with our cities and jurisdictions to kind of help accommodate them as with our infrastructure. Then really had a cool opportunity to work as part of a mitigation program with the State Department of Transportation, basically coming up with a methodology for us to evaluate utility infrastructure and say, okay, this is not a risk to motorists. So, we as the utility can safely claim we won't leave this here. And the state agrees with that. And then that, saves the utility a lot of money and having to do a bunch of relocations for that. My next rotation was into our new product development group, where, like I said, I did car chargers and solar. That's kind of the cool thing for me is I get to be part of the kind of next push of next generation products the utility has been developing. We recognize that with the adaptation of electric vehicles, particularly in Washington State, particularly in King County, that there's a lot that we probably need to learn so that we're able to prepare the infrastructure and be able to run it in such ways to accommodate all of the chargers and all of the vehicles charging potentially simultaneously. So for that, I had the opportunity to work directly with customers and installing level 2 chargers, so sub 10 kW on their properties, whether that's a condo building or apartments or like a workplace, up to deploying some of PSE's public charging stations, which in addition to those 10 kilowatt chargers also included 150 kilowatt chargers, the DC fast chargers. So super cool again to also be able to work with our site hosts, work with the different jurisdictions, such as the City of Sammamish and City of Issaquah on building out into their right-of-way, connecting to our infrastructure, pulling everything in kind of the right way to kind of make everyone happy, develop designs and with customers in mind. And actually, one of the things I enjoyed about that role versus the transmission role is a lot more customer focused, and these are kind of really exciting products to people. So it was always cool to work with someone who was really actually just really engaged with it. Similarly with the solar work, I kind of like I mentioned, that's one of the reasons I wanted to join PSE is I absolutely loved a lot of the work I was doing with Dr. Hillhouse and the CEI. But wanted to do something at scale with it, right? I mean, I think, it's great for us to say, okay, here's our 1 centimeter square solar cell. We made it, 10%, 15% efficient, go us. But to be able to then get that out in a way that impacts people's lives and makes a difference today rather than 20, 30 years down the road whenever we hit the technological maturity was important to me. And PSC was starting to work in that direction. A lot of that is being motivated by what's called CETA, the Clean Energy Transformation Act. So there is a little bit of a legal, fire behind us to green up some more energy supply and deploy some of these resources. But again, with the solar product I was involved in, we call it community solar. And the idea is, hey, we're going to put solar panels on top of your school, your business, your community center, and say, okay, well, now that you're a community member, you maybe go to this community, you maybe graduate from this high school, you can now subscribe to the production from this and get some credits towards your own electric consumption. The idea being that we kind of make it more accessible for people who aren't able to take the cost on of putting their own solar arrays in place, or people who may live in apartment buildings where they can't do that. So really important part of, again, being super customer facing and kind of getting out the products out there people are interested and excited about, in addition to, again, meeting the company's energy burden. And then most recently, I've joined our strategic system planning group as a distribution capacity planner. My role here now is to look 10 years out and be like, okay, for these particular pockets of our territory, what growth is happening, what are our big customers, and then coming up with a strategy to accommodate that. Traditionally, utility is very wires focused. We're going to put substations and transmission lines, distribution infrastructure, so on and so forth. And it's a little constrained. It's a little bit hard to build a transmission line or new substation these days. So kind of the thing we are working on now is looking at what are called non-wire alternatives, where we're looking at, okay, is there a role for utility scale batteries, utility scale solar, fuel cells, things of that nature, to help offset some of the capacity need, as well as supporting some of the operational needs of our system. And in terms of all this sounds like super non-traditional ChemE, and admittedly, I'm like one of 5 to 10 ChemEs here at PSE. But a lot of the skills I learned from being able to make good assumptions, a lot of the critical thinking stuff, as well as just some of the really deep and kind of familiarity with some of the renewable technologies through working in the CEI, I think is kind of what set me up to be successful where I'm at now.
That's great. And Sam, I'd ask, since we've heard from somebody who has spent a lot of their career in the public sector, Katie, and somebody from the private sector, Wes, I'd be super interested, since you've done both in your career, to talk about the differences in day-to-day between your private sector job that you started your career out at and in your public sector now today.
First thing I'll say is what Wes said about how the day-to-day being pretty non-traditional ChemE, but I think the biggest biggest takeaway from the ChemE degree was learning how to learn things that are unfamiliar and really hard. I still do say that my ChemE degree was the hardest thing I did. So yeah, it really has been kind of like a lifeline for just, okay, I don't get how to do this, and now I need to figure it out because I need to deliver it at work. And the ChemE degree and learning really hard stuff has been a guiding light for that. So public sector versus private sector. So I worked in the private sector, specifically at engineering consulting firms for 4 years, and then I've only been at my public sector job with City of Issaquah for about 4 months now. So as a consultant, you are working on a bunch of different projects, and depending on the size of your firm. So I was working at big firms that were all over the country and international as well. I had projects that were all around the country. North, when I was living in Los Angeles, I had projects that were in Northern California, Southern California, and then I had some projects on the East Coast, projects in DC. And so there's I guess a lot more kind of learning on the fly, because each time you're working with a different jurisdiction, as in your client, as a consultant, you're hired to deliver an engineering project for them. And then the owner, be it a private company or, Seattle Public Utilities or the analog for anywhere you live, is sort of on the review side and making sure that we deliver to them what they want us to do. So whereas I was more kind of on the ground doing the work, figuring out how to do everything as a consultant in the private sector, you're given stuff and then you make sure that it meets your code. And that's, Issaquah has its own code, and many cities do. So there are some subtle differences between, sometimes subtle and not so subtle differences between Issaquah code, and then there's Washington code, and then there's also, national laws and acts and stuff. So it's the biggest difference, I guess, is review versus actually on the ground doing the work. Another thing that I like a lot about public sector, and I guess this could also apply if you're working for a small firm, is that all of my projects are in Issaquah. I really like that because, for one thing, I can just get to know all the rules and such in Issaquah, and then become very familiar with it. And, over time, even in just 4 months, there are things I know off the top of my head right now because I've already seen it. Whereas you can have here's one last week. We have a permit center because we review and issue permits for buildings or site work, which is basically, are you doing anything in the ground? Like, are you digging big holes because you want to put pipes in there or whatever it might be? And so we have a permit center that we staff. And so when you get calls from the public about whatever might happen. So last week I got a call from somebody who wanted to redo a parking lot for Costco, because Costco's headquartered in Issaquah. And then I figured out, oh yeah, if you're not going all the way down to the base course, as in you're not going down to the first layer of rocks that's actually touching the dirt, then you don't actually need a permit for it, because you're not going to really do it. You're not going to do anything that hasn't already been done to the earth. So you don't need a permit for that. And then also it was completely contained within private property. So they didn't need a right-of-way permit, because all the work that they were going to do was going to be on a private property. They can just shut the parking lot down. It's a private parking lot. There's enough space for them to put all their equipment, their gear. Construction staging is the term for that. And so now I know next time I get a parking lot call, this is what you got to do. How deep are you going? Are you going to do anything to the ground? No, great. You don't need a permit. You're fine. Whereas if you were doing this on the consultant side, as in maybe like a hired engineer in the public sector to help out staffing a public sector, which does sometimes happen if they don't have enough engineers in house. You know, you might get, if I got that same question about a parking lot in 3 different places, there'd be potentially 3 different answers. And so I do like that it in a way that feels more tangible. I feel like I'm accumulating knowledge and skills such that I get better at my job more and more over time. And rather than trying to learn new jurisdictions, learn new people, and getting to know the people that you work with, and, you know, like building relationships with people who work at all sorts of different agencies. Now it's like I'm building relationships, you know, with people who are in Issaquah, and then there's sort of a short list of developers and, you know, geotechnical review consultants and whatnot that we work with all the time. And so just over time, it's becoming more and more familiar, whereas consulting, things are changing constantly. I guess I'll stop there, but the biggest difference is on the ground doing stuff versus doing review. Yeah.
That's super. And, you know, since I've taught all over the ChemE curriculum, I know for sure we never taught anybody about poles in the ground. We never taught anybody about emissions, particulate emissions from a glass plant. And we never taught about the regulatory permits and requirements of infrastructure. But I was so gratified to hear that you learn to learn. And that is really what engineers have to do. The half-life of our knowledge, of any specific bit of knowledge, is short these days. The world is turning fast, even in infrastructure that lasts in the ground for 50 years. I mean, we're replacing Wes's poles and transformers and things that were post-World War II equipment, you know, 1950s equipment. And it's being transformed. So I'm really gratified to hear that a ChemE degree has done that all for you. And, you know, we're going to transition in just a few minutes. So maybe we can do a very quick comment sort of on, we've heard about the intersection of many areas: policy, law, technology, regulation, human interactions, and the value of that. What has been sort of the hardest new skill as you've moved into this area to be effective in your jobs? Sort of what do you think's been the hardest of all those intersections, none of which I know we've taught you and that you've had to learn sort of as a professional? I will say human interactions, we do teach some of that through teaming and lab mate partners, but maybe I'll start, Wes, just, you know, sort of a lightning 1 minute, or what's been the hardest thing to pick up as you moved into this new field?
I would say the hardest thing is the, I guess, how not quickly things tend to move. Utility infrastructure is very highly regulated. Even though we are a private company, we are still regulated by the State Utilities and Transportation Commission. So any of our rates or any of our plans have to be demonstrated to be prudent to them, because ultimately the costs do fall on our ratepayers. So it's just it's a really interesting set of constraints. As you know, things don't move quickly, we have to justify everything, and we So I might have a tendency to be like, okay, here's a really cool engineering solution. Let's do it out there. And then people are like, oh, let's think about this for a second, because, maybe does this conflict with how we're regulated, or is this kind of how we have demonstrated we've done things before, and kind of making sure that we are being responsible and thoughtful and not changing things just for the sake of changing things.
Cool. How about you, Katie? A quickie.
Politics. I mean, the EPA is a political organization, and we change presidents. I've served under several different presidents, under Bush and Obama and Trump and then Biden, and it is really hard when the way you're doing something changes underneath you. I want to always do the right thing, and I have a very strong opinion about what is right. But we do have to follow our political leadership, and for good and for bad. I think, there's pros and cons to every president. And that's, I think, one of the biggest challenges of being in a federal public sector job.
Interesting. Finally, Sam, any sort of quick comments on the toughest challenge?
For consulting, having a constant stream of work, as opposed to in consulting, sometimes you don't have enough work because you have to win projects. And that's a whole component of the consulting side. There are people whose job title is business development, and there's a whole thing called proposals, where you have to put together a whole document with maybe like 10% done engineer, like plan, like a set of engineering drawings. They'll say 10% drawings, 30, 60, 90, 100. That's usually how they say it. And so you have to put together proposals saying this is like broad sense what we would do, and this is our staff, and this is why you should pick us to do this job. So sometimes you have a lot of work on the docket, sometimes you don't. And so not having that constant flow is sometimes, okay, oh crap, I have too much work, or I don't have enough work right now and I need to fill up my timesheet. On the public sector side, more is that there's more work that can be done. We have 5 engineers and hundreds of projects that people want to get done. And so if we fall behind in reviews simply because there's just too many things to look at, and you can't just look at them too fast and then get something wrong. So getting complaints from the public that, hey, you're taking too long. So yeah.
That's great. So we're starting to get questions in, and I'm going to read the question. And Elizabeth, does that work for you? I'll just read from the direct message. And then maybe I'll ask Katie to respond, because I think it's related to what she had just mentioned. The direct message question is, it seems there's a role that policy plays for your jobs. Does this impact your work directly, or do you have any direct interaction with policymakers? Thanks for that question. Katie, feel free to start.
Yeah, I mean, it absolutely impacts our work, not just when new rules are written and they actually change the foundation underneath which everything we're doing, but also if a new policy comes and says, okay, we're gonna, for example, how we deal with fugitive emissions. So if an emission is released into the building and then it goes out through a vent, is that fugitive? Like, should you not have to control that? Or the fact that it eventually goes out of a vent means you should control it? Well, various presidents have had their administrations sway that back and forth. And so it has a huge effect on what we are doing. I think it goes both ways, though. We have an effect on the policy, on rulemaking, and on what the administration does if we speak up. And so I was never shy to say, look, I need to be put in touch with the rulemakers. It's really important that we give them feedback on what is, right about this rule and what needs to be fixed, push for changes in the rules. We also took a really collaborative posture. So pulp and paper, we do a lot of work in pulp and paper up here in the Puget Sound area. So there's a rule writer who is assigned to that in the North Carolina division. And we wouldn't take an enforcement case against somebody without being on the same page with our policy writer. This helped make sure that we didn't get screwed sort of later if it turned out that the administration disagreed with us, but it also gave us an opportunity to push them and say, look at everything we found. If you've been thinking about it this way, we want you to think about it more broadly. And so, we are sort of the boots on the ground in terms of figuring out each individual scenario, and they're trying to make these bigger, broader decisions. And so I really took it, my whole team, a team of 20, we were really aggressive at making sure to give feedback back so that those policies and those rules and whatever we were working on were based on as much reality and fact as possible.
You mentioned some words that I just want to reiterate. Policymakers make laws, they're generally very broad. And then there's a process called rulemaking. You mentioned rules and rulemaking, and rulemaking is a highly influential period where the actual, how do we implement the intent of a law? How do we get it to work? And I bet Wes, through the utilities and something he had just mentioned, which was the Clean Energy Transformation Act, I think, which is a new state law written very broadly, but then they have to go to the Utility and Transportation Commission and talk about very specific things. Do you want to comment at all about policy and ways that you're influenced by it and ways that PSE tries to influence it?
Yeah, absolutely. So the CETA and our interactions with the UTC are perhaps kind of one of the biggest things. I think it's kind of the biggest, brightest spot where the company itself is focused on policymaking and our influence in rulemaking. Because we do genuinely recognize that there is a very compelling reason to require utilities to green up their electricity supply. But the utility doesn't just have infinite buckets of money to spend, and so we, our like government affairs folks, will work with UTC and work with actually a lot of the different stakeholders as well. So that's actually one of the interesting things about our rulemaking process too, is all the stakeholder engagement we do. So just because PSC comes to the UTC and says, okay, this is what we're proposing, this is how we're thinking about doing this is how we're interpreting things, we get folks who might be, for instance, the Sierra Club or different jurisdictions, or I'm thinking, I think an organization called Sense, Coalition of East Side Neighborhoods for Sensible Energy, I think. Who all come in and go, okay, well, this is how we think about you building your infrastructure here. This is, oh, we don't think you guys are being aggressive enough. We think you're kind of just being too I guess, timid in your deployments of green energy. And so working through that process is ultimately how we get to a point where the UTC commissioners approve kind of PSE's plans, which directly influences the level of work that I do. So this is, again, thinking about like a community solar program, for instance. I believe we were targeting something like 20 megawatts of solar to be installed under that program. And that number did come up through the iterative process of our rate cases to the UTC, as well as a lot of stakeholder engagement, to kind of come up with a number that the utility thought was realistic, but also that our customers, the people we're responsible to, thought, was PSE making a good faith effort at actually trying to get some of this stuff out there. Another interesting one I'm thinking about too is in terms of how like policy makes its way to Washington State. We often say that if California does it, it'll make its way up here in short order. So one of the things I am kind of tossing over and have some feelers out for is the regulation of sulfur hexafluoride gas. So in substation switchgear, we can have open air substations where the air itself actually is our dielectric medium. So we open up some contacts, we have our little arc whips, and eventually we break the arc that way. It takes a lot of space, but tried and true. But we also can use what's called gas insulated switchgear, where they kind of the same function. It's basically a big old breaker, and they're filled with SF6 gas, which actually extinguishes the arc. The crazy thing is SF6 gas has something like the 25,000 times the potential of CO2 in terms of greenhouse gas warming potential. So there is some rumblings over from California where they've started to more stringently regulate that. And so that's actually something I'm trying to figure out here as I'm now planning out substations and infrastructure for us moving in the future, is what risk is there for me to planning a substation that uses this SF6 insulated switchgear? Will I be able to maintain it in 20 years, 40 years? Will I be able to build new ones? And so that's something that we're starting to think about from a policy side, and certainly would also weigh in to be like, okay, well, trade-off is, if you want us to do open air substations, we're gonna have to take a lot more land in downtown Bellevue, in Redmond, in Issaquah, and Sammamish to build some of this stuff. Downside is, or if you want us to build smaller, then we can do the SF6 gas, but then we need to talk about what that process is.
Katie, you've got your hand raised. Oh, you're muted though.
I just wanted to add, it's so interesting because I did a lot of ozone depleting work. And so, yeah, in the policy side, we had to figure out for every chemical with a high ozone depleting potential, what should be an allowed use, because we tried to ban them all, but there's some acceptable uses. And so there's a whole team in the headquarters that actually works on allowed usages and how much and how we're going to bring it in and import it. And there's all sorts of, so it's very interesting, how it all touches a little bit of everything, and we're trying to learn from the energy sector so we can make sure we make the right decisions, but people try to get away with a lot too. And yeah, it's fascinating.
Well, I will just add, and then I'm going to go to another question to Sam, that I'm surprised that the Washington State's 2019 super pollutant laws don't cover that because there's a lot of chlorohydrocarbon type things, but we won't cover that here because I want to keep moving through the audience questions. We had a direct message question I'm going to go to Sam on, which was, what was your favorite class in ChemE? And what about the best extracurricular activities you got involved with?
Let's see, I think my favorites were ChemE 310, the first one, because that's when I thought, oh, wow, this is cool. And I could actually do this. ChemE 435, computer skills. I think that was the number, because that was sort of where I first learned some like Excel tricks, and also MATLAB I haven't used at all in the work world, but starting to learn Excel tricks, and that sort of planted the seed for me to get nerdy about like learning keyboard shortcuts and just like trying to find fast ways, efficient ways to use any sort of program, which has been very helpful. Keyboard shortcuts are your friend. 100% they are your friend. And you can learn anything about any shortcut for any program on YouTube. We live in an amazing time. Let's see, third favorite was process controls with Professor Holt, because that was just super cool. It was just cool. It was just super cool, and also very hard, but really cool.
That's like where you discovered math really works in controls. Math,
yes,
it works.
And it works, and doing the concept of doing differential equations in Laplace space, which is crazy. I cannot say that I have done that again in the work world. However, it was certainly it was a perfect example of this stuff is really hard and you can learn it. And if you can learn one really hard thing, you can learn another really hard thing. Let's see. For me personally, my extracurricular that I liked was the jazz combos through UW School of Music. That was quite a release during the week. I don't know if that was the answer you're looking for, but for me personally, that was the answer.
The right answer is the thing that keeps you motivated, interested, and engaged.
Yeah.
And there's a million extracurricular opportunities. And so there was not a wrong answer at all. And I'm glad to hear that. Katie, I think I saw a little hand raised, or was it just reaffirming some of the things you were hearing?
I think I was reaffirming, but I'm happy to weigh in if you'd like me to. So my favorite thing I did was a senior project in fuel cells. I got to work with mechanical engineers and chemical engineers, and we actually ended up digging in the third quarter a lot into the regulatory background of what it would be like to build a business. And that was how I ended up getting my job at EPA, because after studying the regulatory impacts and really diving into the rules, they were like, oh, well, you're totally ready to do enforcement. You know how to apply a particular business to the rules. And so I learned a lot from doing something outside of the main school. That was a year-long project. And then I was really active in Girl Scouts. I volunteered and I led troops in underprivileged areas, and wasn't really a school extracurricular, but it was a really important part of sort of keeping me sane and grounded through my college experience. I'm also happy to talk about public interaction if you'd like me to, or if you want to go to
well, why don't you just continue on, because then I'll go to Wes for the next question.
Yeah, so we do interact quite a bit in the public, and our phone numbers are public. People can call us and ask us any questions.
Actually, maybe I'm going to read the question first,
Oh,
just
yeah,
so the
yeah,
audience knows.
yeah, yeah. Sorry, go
what.
ahead.
Okay, what type of people or positions do you work with every day? It seems like there would be a lot more direct public interaction than what chemies in other fields would do. No, go ahead. I'm sorry
Yeah,
for
so yeah,
interrupting.
our phone can ring at any time, and so we could end up dealing with a question that somebody has, a concern, a complaint, a frustration. Someone might be really impacted by something going on in their community. We have an odor, and I have headaches all day. You know, it's a huge problem, and you really feel for them. You know, it's hard. I also participated in public meetings, which, you know, with people with their pitchforks wanting you to do more, and you trying to explain how you're doing all that's in your ability. On the flip side, you know, we'd sit down and negotiate with the lawyers of other companies who are getting paid, you know, thousands of dollars an hour, and, you know, are trying to, you know, screw you over essentially. And then even with the head of EPA, we had meetings that went all the way up to the administrator level. So I would say in the public sector, at least at EPA, one of the coolest things was it's not super hierarchical, and that a new person kind of gets stuck doing little stuff. I was leading a national case that settled for $120 million within my first year at EPA. And so I think having it gives you a lot of ability to interact with many different people. And if you're interested in new experiences, they're all waiting for you at a public organization, at least like EPA, because anything could come on any day.
That's great. So I'm going to move to a question for Wes. And that was Wes. We got to follow up. There was an audience person in person. Thank you for coming and fighting your way through traffic, in person people. What type of solar systems are you installing? And, you know, sort of what are you seeing in terms of the transition in infrastructure? How might your job have looked different 20 years ago? And then we'll move on after that answer to sort of a rapid fire round.
Yeah, absolutely. So primarily for the community solar program, we're installing bifacial monocrystalline silicon panels. So the idea with a bifacial panel is that they can actually get some yield from the albedo, from the light coming off of like the roof on the back of it. Because a lot of times these are roof-mounted systems on a light-colored roofing membrane. So, you know, under ideal conditions, these would be operating at like a 26% efficiency. The systems themselves are sub 500 kW, and that's done more out of convenience. Just because we as the utility say that sub 500 is a safe number to install without triggering millions of dollars of infrastructure and substation upgrades. And so even though this is a utility project, we can't treat ourselves any differently than we would any of our customers. Again, that's kind of part of our regulations and responsibility to our customers. And these are all simply just protected by the inverters. So they're relatively easy for us to put in. We do have some big cornerstone projects out in like Kittitas County that we have power purchase agreements. So they're being developed by a third-party developer, and then we just sign contracts to go and buy the power. These are also monocrystalline. I think there's monofacial panels, but these systems are 5 to 10 megawatts in size. In terms of shift in the infrastructure being used, I would say that, I guess, I feel like such a very broad question. The answer is most certainly yes. You know, 20 years ago, even probably 5 to 10 years ago, we would not have contemplated things like solar or batteries or fuel cells or anything of that nature in terms of developing our system. Our solution would be, okay, we're going to get more of our centralized generators, whether that's hydro or natural gas. We're going to run the transmission lines. We're going to run the to substations. We're going to then build out the distribution networks and so on and so forth. And now, again, there's a recognition that, hey, maybe there are ways for utilities to do this without having to build wires, having to build substations. So we are seeing more deployments of solar. That's kind of where the company is now in terms of like our biggest kind of next generation distributed stuff. We actually see a lot more applications for like I guess smaller micro rotating generators, something like micro hydro or smaller gas generators or micro wind turbines. And we are starting to play with utility scale batteries. And that's actually, that's gonna be super interesting because we recognize it's a great way for us to kind of back up power in areas where the system maybe isn't, for some of our more rural areas, and kind of, again, avoid us having to build bunches of new wires and kind of reducing some of that infrastructure impact on people.
That's great. Thanks. We're going to go now just to a very short answer, 2-word answers. Sort of, Katie, what was the best advice that anybody's ever given you that's career related?
Be willing to be wrong.
Excellent. How about you, Sam? Oh, you're muted. I'm sure it was brilliant, but I didn't hear it.
Sorry. Write short emails and use bullet points. Make them as easy to read as possible. If something is easy, functional, easy, repeatable.
Excellent. 3 words. That's good. Excellent. So how about you, Wes?
This one actually came from Dr. Hillhouse. It's be extremely precise in your language. And in that context, it was for journal articles, but this is something that is absolutely true for any of our stakeholder engagement, any of our regulatory filings, even just working internally. So kind of similar to Sam's response, be absolutely precise in the things you say.
All right. Well, thanks, everybody. I believe we're at time. Is that correct, Elizabeth? Any?
Perfect timing. Our bell just rang. So we'll give a round of applause from our online and in-person audience. Thank you to all the panelists for joining today.